Hey, good afternoon everybody, and welcome back to the channel. Very warm day here today in the subtropics, about 80 degrees, which feels a little warm. But we caught great solar. All systems are up and running, fully charged. We're going to take a look at a bunch of different fuses, breakers, see what they're made of today. All right, guys, so we all use a various combination of these in our systems, or a lot of us do. I've seen just tons and tons of systems that are using these type of breakers, these type of A&L fuses. I use many of these in my own systems, and I have blown a couple of 100-amp fuses in the past that I've showed you guys. Both of those were due to my own error. And what I want to do today is go through these and see how close they blow or break according to their specifications. And we've got several different brands. We've got two of the Blue Sea, which the Blue Sea breakers are a little more expensive than many, but they have the reputation of being really solid breakers. And I have used them, and they've worked perfectly for my systems actually. And then I've got some of these cheaper ones. This was like a 4-pack of these, no name on them whatsoever. Who knows who made them? Super cheap, 4-pack for like 25 bucks. I think that's what that was. We've got a A&L fuse from, this is Spartan Power, fuse block and fuse from Spartan Power. We've seen them around a lot for solar equipment. Windy Nation, seen them around a lot. And then this one up here is a REDODO block and fuse. So we're going to put them through the test. We're going to use this REDODO 300 amp hour lithium iron phosphate battery for this test. We know that this has a 200 amp BMS on board, but so I'm going to try and blow these without making the BMS trip. So I'm not going to be running 200 amps through these, but all of these should fail long before the BMS would trip. And we're going to run our power with this Top Bull 3000 watt pure sine wave inverter. And I've got this shunt tied in, so we'll be able to monitor how much current we're pulling in amperage. We're going to put the fuse and breakers right here, and we're also going to run a watt meter, and I think I'll be able to catch all three of those in real time right there. This is the remote control switch for the inverter, and then we're going to use the New Wave induction cooktop, and I'm just going to put a pot of water on there so I won't be, or so I have something to make this work on. And it has various settings that we can definitely get it high enough to hopefully trip and melt all of those fuses. So let's get the first one tied up here and let her rip. And of course I've got this in standby. Better to have one and not need it than, well, you know. And this is for my own experiment, guys. Don't try this at home. I have nothing to do today, and I'm going to see what kind of trouble I can get into. So just for my own experiment, I'm curious, see how close these things will blow at their rated specification. AP, you know what they say about curiosity and the cat, right? Better back off, we're ready to go. Okay, first up is the REDODO block and fuse. We got a 60 amp fuse on there. Shouldn't be too hard to blow. Got the shunt on, and the inverter is not on. Let's go ahead and turn the inverter on just to make sure everything's working. Shows just a couple of amps at the moment as that fan's running on the inverter. And let's go ahead and kick this on low. Try and get that fuse in there, and you can see we're drawing 49 amps, 496 watts, 474 watts. Everything's running. 50 amps, So it's holding the 50 amps okay. Let's kick it up a little bit. I'm just going to reach over and kick the setting up on my cooktop and keep the camera rolling on this. You should see these values jump up. There we go, 50, 593 watts. I'll just keep the camera close to the amperage. Since that's what we're looking at, I'm gonna have to kick it up a little higher. It's holding 50 watts okay. Let's go up to the next setting, which is medium on the cooktop. There we go, 65 amps. $760 some watts, exceeding the rating of the breaker. Cables are nice and cool still. 66 amps. Let's kick it up a little higher, up to medium high on the cooktop. 75, 83 amps, 83 amps. Still running, 967 watts. Let's go higher. Going to the high setting on the cooktop. 84 amps is not blowing that fuse. Here we go. 86, not blowing. Almost 1,000 watts. I'd back off if I were UP. Back off. 87, let's go to the next highest. No, that's not gonna work. Back off now. Danger zone. Next highest setting. Over 1,000 watts. .88 amps, and that fuse is not blowing. Okay, good information. The cables are a little warm. Let's see what this one feels like. A little warm. I should be able to get this cooktop up a little higher. Okay, I'm gonna have to break out some bigger guns, I guess. I've got that cooktop all the way. That water's getting hot, but that fuse won't blow. Okay, I'm gonna pause this, turn it off. I'm gonna break out a bigger gun. Okay, I've broke out the bigger gun. We've got a heat gun. This better do it, right? And we've got it plugged in as well as the, I think I'll unplug the cooktop and just plug this in here so we can get an accurate watt draw. At the same time, we're getting an amp draw. I was hoping to go up a little more incrementally on this by using these settings here, but I had it all the way on max and that fuse didn't blow. Okay, let's turn the heat gun on. Low, I believe this is. Yeah, this is low, 50 some watt, or 50 some amps, 52.5 amps, 633 watts. Okay, I've only got one more setting to go on the heat gun, which is high, so I'll turn it off. This should definitely blow, and if it doesn't, then I'm not gonna be liking this. So here we go, high. Come on, there we go. .106 amps, 1,200 watts. Oh, And there it blew. But it took, what did we see, 1200 watts, and there you can see that fuse did blow. Way higher than I would like that thing to have blown on. When I put one of these in, I wished it would be closer to the blowing capacity. That was quite a bit higher, but it did blow at, you know, whatever we saw, 100 and some amps. Okay, so that was the Renogy. All right, so I'm going to pull this one out and put the next one in. Okay, next is the Windy Nation fuse blocks and fuse, and these are the fuses, the A&L fuses that they came with, and it was the same on that Renogy back there, which we finally did blow. You know, I just ordered those fuse blocks with 60 amp fuses for this experiment, and these are the exact ones they came with, and they look identical. I'll say this one and that one looked identical. And I did make a little mistake. Instead of using my trusty resistor here to make the last connection, you can see when I did touch that on there, I got a little spark burn right there. So always use one of these when you're getting ready to make your last final connection, so you can kind of pre-charge everything. So I've got it ready for the next one. The fuse looks fine. I think everything's good. And I did disconnect the watt meter for this, because I do want to kind of run it up incrementally if I can, and see if we can get a little closer, you know, than having to run it up to 100 amps to blow a fuse like we did on that Renogy. So I've got both the cooktop and the heat gun now tied in here, and let's just run it up and see if we can do it more incrementally and see where this blows. So here we go. The fuse looks good. Let's turn it on. Oh, dang. Had the heat gun still turned on, so I turned that off real quick, just in time. Okay, so let's start with the cooktop right here. 2 amps. Boy, it did jump up to 100 amps there real quick, didn't it? Okay, let's go to medium on that right off the bat. We know that should hold, and start. Medium setting, drawing 50, 60 amps, 65. Again, this is the Windy Nation block and fuse. Let's kick it up a little higher, go up to the next setting, which is the high setting. Jumps right up to 70, 80 amps. Let that run a minute. Let's go to high. It's holding 83, 84 amps. Kicking it up to high. '86. Let's go to its max setting. Holding it at about 86 amps. Okay, I'm gonna stop that. It's not blowing at 86 amps. Okay, I'm gonna knock it down back to low. And now I'm gonna turn the heat gun on low. Which is about what it always does. Okay, now see if I can catch a little more of an incremental jump. So we got the heat gun on low, pulling 53 amps. I'll kick this on low. I'll kick it up to medium. Over 100 amps, and there's the fuse. Looks like it's melting to me, and it melted right there. So again, that took over 100 amps, didn't it? Okay, so that was the Windy Nation. Okay, next up is the Spartan Power fuse blocks and fuse. This one did come with an 80 amp fuse. And I will say that out of the previous 2 blocks that we used, this one is a much heavier block on it. Just feels more beefy than these 2 I used back here. Very lightweight, nothing really to them other than the bolts that fuse ties onto. But this does have a very kind of a solid feeling block to it, actually, which is different. And on this one, I'll try to avoid the spark, so I'm ready to, you can see there. Hopefully now when I put the cable on there, it won't do a burn. We'll see. Yeah, just like that. That's why you use those resistors. So let me use my other hand, tighten this on, and let's see if we can blow it. And this Spartan power block does come with a little plastic cover that snaps on over the center of that fuse, but we'll leave it off for our viewing pleasure of when that thing blows. And it just has a solid kind of bar right there, as the other one that we saw, they have kind of a squiggly little bar in there. Okay, let's turn our inverter on. I got to remember to turn these things off between running these fuses. Okay, so I turned that air gun or the heat gun off. This is off. Let's turn the cooktop on first. Let's just go start with medium. And press start, Bob. Okay. So again, this is an 80 amp fuse this time. There's 50 amps. We know that shouldn't blow it. Let's go up to the next highest setting. 60 some, 72 amps, 81 amps. Let's see if this one blows closer to its rating. All an experiment, guys, for your viewing entertainment. Okay, 84 is not doing it. Let's go up to the next highest setting, which I just did. 86 amps on an 80 amp fuse. Okay, and I'm gonna go ahead and max this cooktop out. And I just did. It doesn't seem to, the last 2 settings don't really seem to change that amperage, do they, on this particular cooktop? Okay, so 87 amps. Let me just check the temperature here. A little warm, just a little warm right there. Holding 87 amps and still running. Okay, let me kick that down to low. And let's turn the heat gun on. And I'm gonna reach over here on the low setting to start with. Okay, 50. Now I'm gonna go up incrementally on the cooktop. Go to medium low, 108 amps, and there it's burning. I can see burn. I saw the blade, oh, it's melting, still running at 110 amps. You can see it changing color. It hasn't blown yet. It's getting hot. Come on. I'm gonna just let 110 amps, and that thing's glowing now. She's about ready to blow. 80 amp fuse, 110 amps. Oh, look at that thing, glowing red, still not breaking. Ah. All right, the drama. All right, we blew all 3 of those, the Renogy Windy Nation in the center and the Spartan Power there on the end. And you saw what it took to do that. And now we've got this extremely cheap 50 amp breaker, and we're going to see what that will do, where that pops open. Okay, here we go. Inverter on. Just 2 amps on that startup fan with the inverter. Okay, I'm going to go ahead and put the cooktop on low. Well, that's not pulling very much. Has it started? Yeah, let me kick it up to medium and see what happens. There we go. Okay. 60 some amps. What we're hoping is that this will snap open when we exceed its capacity. It's a 50 amp breaker. 67 amps going through it. Let's kick it up medium high on the cooktop. 70, 81 amps, 84 amps, 85 amps, 86, 86 amps. Let that hold there a minute. Check the temperatures. Slightly warm. Okay, let's kick it up a little higher. High setting, 88, 89. Oh, now everything kicked off, but this thing did not snap. Wonder what that was. Interesting. I think the inverter shut down. Why would that have happened? So I'm telling you, the back of this, I've got my fingers on the back of this thing. It's hot back there. My cables are cool, but the back of this breaker, very hot actually. Just almost too hot to keep my fingers on there, but not quite, but pretty hot. Okay, let's try the heat gun on this and see what we can do. $50 some amps. Let's kick it all the way up to high and see what happens. 100 amps, 110. 110 amps, nothing happening. And that thing's not breaking, is it? But the inverter must have just kicked off, right? Yeah, it did. Okay, so the inverter kicks off before this snaps open. Here we go again, one more time. Heat gun on high. And again, the inverter kicks off before this thing snaps open. Okay, curious. And man, I'm telling you, oh, cable's just barely warm. Just barely right there, but that's just dissipating the heat off of the back of this thing. This thing is blistering hot, I'm telling you, blistering hot. Okay, I'm not gonna be putting any of those in the system anymore. And let's go on to the Blue Sea. All right, we've got the Blue Sea 50 amp breaker hooked up now, and we've got it clicked in there nice and tight the way it should be to be able to open up the circuit. And let's kick on the hot plate right off the bat. Oop, turn inverter on. Here we go. Okay. $50-ish amps. Next highest. 60. 65. Nice and cool. The unit is nice and cool. Next highest setting. 72. 81, 82. Let's go up to high, which doesn't seem to take too much more amperage from medium high all the way up to the highest setting, but let's go ahead and kick it up anyway. 86. And all the way on max. Now this, which feels like a much heftier unit than that one back there, I mean, it's just got some weight to it. This block is seriously heavy. 87 amps. And there we saw. Okay, so that one snapped open. Okay, so Blue Sea is what's going on my systems for sure. I will go through and make sure that any of the cheap ones that I may have put out there, I don't want to be running that kind of amperage before it breaks. So we caught that one pretty good. So let me turn this off here and turn this off. And let's just see, did it get warm before it actually, yeah, nice and cool to the touch. So this thing didn't get hot at all. Where that one back there, I'm telling you, that thing was blistering hot. I can feel just maybe the slightest warmth. I mean, just maybe the slightest warmth on the back of this, but it's negligible really. So that thing popped right open. So giving you guys a good idea that just because it says, you know, 50 amp breaker, I mean, you saw it took us up to what, 80 some before that thing popped open. So keep that into consideration when you're building your systems. You know, it's going to run a little higher, right, than it says. It's not going to click off right at 50 amps. And sometimes it doesn't click off like that one back there. You know, it just never did. The inverter shut down first. So keep all those things in mind when you're building your system. So now all I've done is reset this, you know, push that breaker clip right back in there. So now it's reset. I'm going to see if I can't catch that a little more exact on this time. So inverter on. Okay, now let's go right to the medium on the cook plate. And I'm kind of curious if it runs on this 65 amps just for a little longer than I was letting it run before. Would that eventually click over? A little lower than having to go up to 80 some, but yeah, super, super cool. Okay, let's go to medium high and see if we can't catch that exactly when it breaks. $84. I'll let that run a second. Seems to be holding at 84 amps, okay. Super cool to the touch, everything's cool. Okay, next highest setting should do it. That's what it did it before. 84 amps still holding, 87. I'll let that run just a few seconds longer. There it went. So we caught that at 87 amps. Okay. And still, yeah, just this teeniest bit of warmth on the back. Not anything that would really worry me in my system at all. Where that one, like I said, that one back there, I don't want anything getting that hot on my system whatsoever. The cables are staying extremely cool. And that's what we're trying to protect, right? We're trying to protect our wires and cables. We don't want anything melting. And that one, I don't have confidence in. That's why they're probably 25 bucks a 4-pack. Whereas this is probably closer to, you know, 40 or 50 bucks just for this breaker. But Blue Seas has a good reputation. So far, you know, I really like the Blue Sea. And the nice thing about this is it did pop and break the circuit, which is good to protect our cables and wires. And the nice thing is, I mean, it never did get hot. And the other thing is, now all we have to do to reuse this is reset it like that. And if you wanted to go in and disconnect your system, all you have to do is press that button and it breaks the circuit. So yeah, as opposed to those where we fried the fuses, I mean, you have to put a new A&L fuse blade in there to make those operational again. Of course, that goes without saying, but you know, this one, you know, if it pops, you know, you can investigate why did it pop, what were you doing that made your breaker break, and make whatever adjustments you need to make in your system. But this is reusable now, so I like that. Okay, so now, last but not least, let's throw another Blue Seas 100 amp breaker on there and see. We're gonna have to run it up. Probably have to run both devices to get that thing to snap. Okay, for our final experiment today, we're using the Blue Sea 100 amp thermal circuit breaker. Okay, so inverter on. Startup current, a couple of amps. While that fan's running, let's kick it up to medium on the hot plate. Start. And here we go. Now we're going to have to run this up. We're probably going to have to turn that heat gun on too, but we'll run it up a little slow just to make sure it holds within that 100 amps. And let's kick it all the way up to max. $83 amps, 84, 85 amps. Everything's fine. Of course, it's nice and cool. Again, these are pretty beefy, heavy duty. I like the Blue Sea equipment. Okay, so obviously it's not going to trip a 100 amp breaker at 85. So let me kick this back down to medium. And then let's go ahead and put the heat gun on low. 127, 128 amps. 127, pretty steady. Got the hot plate and heat gun going. Let me see if I can kick that hot plate up a little higher. The water is boiling. Here we go. 136 amps, 141, 150 as you can see. No, maybe just the slightest bit of warmth on the back of it. Yeah, cables are a little warm. 152 amps. I would think that the warmer that got, eventually this would break even at that, but let it go a second and see what happens. Nothing. All right, let me kick the hot plate down a bit, and then we'll turn that heat gun on high. Okay. What are we drawing there? Let's kick it up a little bit more on the hot plate. Get some, there we go. And let's go to high on the heat gun. There we go. 188 amps. There we go, 189 amps, finally tripped it. Okay, so as we can see, these things don't trip out exactly what they say they will, and so you got to keep that in mind. Now, I will say the back of this is pretty darn hot as well. So there you go. Okay, well, I stand up and stretch my feet from being in that crouched position the whole time here, which was a little rough on my feet. Okay, so that's a lot to think about, right? That's some good information for all of us, that you put a 100 amp fuse. It doesn't mean like when you're drawing exactly 100 amps it's going to pop. So you want to be keeping that into mind, right? I mean, it took considerable more amps to make things start breaking and melting. So size of your breakers and fuses matters, right? But the main thing is you don't want them to be getting so hot that you're going to be melting wires and that these things never break. So the wire size or the cable size you're going to be using matters for how much you're going to be pulling as well. But I hope this was informative for you guys, just to show you like how these things operate in a real world situation under real loads. Yeah, I think that's about all the trouble I can get into today. So I hope you guys enjoyed the video. Thanks for tuning in. I hope that gives you some things to think about on your systems, and maybe you'll be going back and checking some of your breakers and fuses and even making some changes in your system. Anyway, food for thought. Have a great day. I'll catch you guys on the next one. Aloha. Yeah. Whew. Didn't blow anything up. And the cats are still here. Oh boy.